rotating around this line. We already set up our shape here. We've got 9 minus x squared and y equals 12. We decided we're rotating this thing like a pinwheel. So over that line, y equals 12. That's what gave me this line right here. Okay, so we are finding volume. If I'm finding volume, what do I got to do? Integrate area. So again, just like every single problem we've done this week, if I put area right here, I win. So I got to integrate my area. I'm rotating this thing in this manner. I'm going this way. Is this a dx or a dy problem? Dx. And one of the biggest things that students screw up with this is, oh, it says y equals 12. That's the line I'm rotating around, but it's dx. Yeah, because y equals 12 is the same orientation as the x-axis. Okay, so this is a dx problem. Show me with your fingers, what do you think bounds are going to be? It's x values, so I'm looking for x bounds. I'm going from 0 until 3. The only thing I have left to do is fill in that yellow part, find the area. So if I'm talking area, I need to know what my shape is. What is my cross section going to be? I have two options since I'm rotating. It is either a disc or a washer. Which is this going to be? This is a disc problem because I'm flush up against the line I'm rotating around. I'm right up against this line right here. It is going to be a disc problem. So it is just area of a circle. A disc just means a circle. It is pi r squared. I just need to know my radius. I had a student earlier today that got saddened that I did this, but I've got a pi, so I can just throw that pi out in front. You don't have to. You can leave it in the integral, but I'm going to pull it out in front. All I need is my radius squared. Since this is a dx problem, I'm rotating up and down. Okay, I'm going to find my radius by going from the top line to the bottom line. Don't get confused by this line we hand drew in. Okay, that's nothing. We drew that in. We have no idea what that line is. I want to know the top line that we have drawn and the bottom line. So thoughts, tell your neighbor, what do you think your radius is going to look like here? What do we think? Drew, what's your top line going to be on this picture? The top line? The top line is 12. So that's the line we're revolving around. If we're revolving, you got to always include the line you're revolving around. I'm revolving around that line 12. It is the furthest from the x-axis, so it is the biggest one. 12, and then what else do we need to do? Minus 9 minus x squared. He's got to throw that in parentheses. There's my setup. 12 minus 9 minus x squared. Everybody see what's happening there? Big line minus little line. If I drew my circle again like I had drawn, this is the radius from here until there. All we have to do is then type that in. It is 12 minus parentheses 9 minus x squared. Close my parentheses. This is hard to type in because there's a whole lot of parentheses. Okay, you've got to be careful. You can do it however you want. Make sure you're typing this in as I talk. Okay, the one way I would suggest you doing it is under y1, type in that part inside the parentheses. You don't have to, but if you get to this later on, there's going to be a whole lot of parentheses. 12 minus 9 minus x squared, I saved as y1. So then when I type this thing in, I can just go pi, and then go math 9. I'm integrating from 0 until, what do we integrate till? 3. And then it is just, yeah, I hit all kinds of wrong buttons, sorry. You should not get a negative number.
I got a negative number.
Alpha F4, Y1. Y1 squared dx. Let's see, thumbs up if you got a number bigger than 400. Thumbs down if you got a number less than 400. Bigger than 410. We should have gone under. Your number should have been 407.150. What did we do wrong if we got negatives? Forget to square it?
No, I squared it.
Okay. Just be careful there. Okay. The hardest thing about today is typing it into your calculator. Once you know the setup, then it's just a button push. 407.150. Questions on the first one? Let's try it again. Let's go to example 2. Find the volume of the solid obtained by rotating 9 minus x squared and y equals 12. So we're doing the same two lines. We're still on the interval from 0 to 3, so I'm still talking about this same section. I'm going right here. Here's the shape I'm going around. This time, though, I'm revolving around the line y equals 15, so that's this line right here. Tell your neighbor what's going to be different about this problem than the last one. I heard a whole lot of worshers out there. Jack, why do you think it's going to be a worsher here? Good. We're rotating two lines, and there's this space in between here. And so if there's a space in between the lines you're rotating and your axes that you're rotating around, we should have a washer here. Okay? So we're integrating. Show me with your fingers, what do you think your bounds are going to be? Show me with your fingers, what do you think your bounds are going to be? So you're showing me those numbers. Are those x values or y values? It's an x problem. It is 0 to 3. It's just like the last one. Okay? When we set this thing up, the same rules apply. I'm trying to find volume. So if I'm finding volume, all I need to do is integrate area. So area is going to go right here. When we decide we're doing our cross section, I'm doing the area this time of a washer. So to find the area of a washer, we go big circle minus area of the little circle. We can factor a pi out. It's the big radius squared minus the little radius squared. And all I have left to do is decide what is the big radius and what is the little radius. Take a second with your neighbor and see if you can decide what goes where. Here we go. We're looking for big radius. Courtney, what do you think here on the big radius? I always want to include the middle line. So whatever line you're rotating around, you always got to include that. So since we're rotating around 15, 15 is going to be a part. So we're going top line to bottom line. So 15 here is my top line. Does that visually make sense to where we're going from? So we're going from 15 to the bottom line. What is that bottom line going to be? But it's 15 minus 9 minus x squared. Up through that in there too quick. 9 minus x squared. Throw that in parentheses. You always need to include the midline. Whatever line you're rotating around, we have to include it. So it gets me that right there. That's my big radius. 15 minus that 9 minus x squared. And then we got to take it and square it. Then I want to find the little radius. Show me with your fingers. What do you think the little radius is going to be? Your little radius should just be 3 because we're taking the middle line. We always include the middle line, 15, minus the other line that we rotated. Well, the only other line we rotated was the 12. 15 minus 12 is 3 squared. Take a second, type it in your calculator. Let's check. Thumbs up, bigger than 600. Thumbs down, less than 600. 800. 750. 700. All right, so somewhere between 700 and 750. Type it in, hit enter. 746.442. Did you put pi in the front? Did you square everything? Those are the things you're looking for. Okay, if you didn't get that answer, look for your parentheses, look for your square. 746.442. Let's go to the back side. Number 3, find the volume of the solid formed by y equals x squared and x equals 2. About the x-axis and the line x equals 5. All right, so I graphed this thing already. This is x equals 2. This is y equals the square root of x. We're revolving it around that blue line in the middle. That's x equals 5. So that yellow circle represents what it would look like when I revolve this thing. I would have it coming across to here. It would look something like that. Yes, ma'am. Oh, my fault. My fault. Y equals x squared. Thank you. I was in the midst of switching them in my brain. Everybody understand what's happening here? We're revolving around the line x equals 5. Show me with your finger how you spinning this thing. We are rotating this right to left, right to left. This is a ceiling fan problem. We are rotating it this way. Okay, we are going around just like that. And so to find volume, we are going to integrate area. If we are rotating it the way we just stated, is this a dx or a dy problem? It is a dy problem because we're rotating like a ceiling fan. Show me with your fingers, what are your bounds going to be here? Show me with your fingers, what are your bounds? We are getting 0 to 4. Those are my bounds. Disc or washer? Washer. Take a second with your neighbor. See what you can do to write your radii. Here we go. We are looking at this problem. This is a dy problem. So we're rotating. And as we rotate, we're thinking right to left, right to left, right to left. We always have to include the line you're rotating around. So I'm rotating around x equals 5. So we said it's a washer. It's big circle minus little circle. So I need to know what my big radius is and my little radius. For both of them, it's going to include 5. Is 5 the line furthest to the right? Yes, so for both of them, it is 5 minus something. Okay, it's big radius minus little radius, right to left. So my first one, my big radius, is going to go 5 minus what here? Angela, what do you think I'm going to subtract? Yes, we are subtracting this line right here, but it's a dy problem. So what do you need to do with that y equals x squared? Square root. And so it is 5 minus the square root of y, because we need this to be in terms of y. So it's 5 minus the square root of y right there. 5 minus square root of y, all squared. Everybody go on the first one. Show me with your fingers, what is the second radius going to be? Second radius should be 3, because it's 5 minus this other line, and the other line is 2. So it's 5 minus 2. My radius is just 3. Take a second, type it in, get me an answer. Second pi, don't forget that pi. Math 9. We are going from 0 until, what do we go to, 4? 0 to 4. And then inside of parentheses, my first one was 5 minus the square root of x. Close those whole parentheses because we want to square that whole thing. Minus 9 dx, hit enter. There is my answer, 58.643. Questions there? One more. Graph that last one. Try it without me showing you the graph. See what you can do. If you've forgotten how to graph y equals 2 square root of x, plug in some x values. Okay, and y equals x, we're going around the line x equals 4. Oh, I graphed my line a little short here. Sorry. That's better. We're hitting that point right there. So we're graphing around the line x equals 4. That's this line right here. Okay, that's the line we're rotating around, x equals 4. So when I set up my integral, we're finding volume, we integrate area. Show me with your finger, how'd you spin it? dx or dy? dy. We're spinning this direction because we're going around the line x equals 4. Okay, it is a dy problem. My bounds are going from 0 until 4 because those are my y values. Okay, that's the area. That's awful shading, but we're going this section right here. So we're going from 0 to 4. Disc or washer? It's a washer problem for sure because there's a gap in between. So to find the area of a washer, it is pi, big R squared, minus pi, little r squared. I can take pi out. All I need to know is what the big R and the little r are going to be. Parentheses squared minus parentheses squared. I need my big radius. Cassie, where do you think your line is going to start for your big radius? At 4, at the right line. So she's starting at the right line of 4, and you're going to go until when? 4, good. 4 minus. Perfect. She said we're doing subtracting this line right here, but we have to change it because it is a dy problem. We need to put it in terms of y. And so what we do to here to solve this thing, divide by 2, and then square it. So y over 2 squared equals x. So that is what she's subtracting. Y over 2 squared. 4 minus y over 2 squared. So when you type this into your calculator here in a second, we just added another set of parentheses and another square. It's really easy to make a mistake here as we do it. There's that one. Then we're doing the second one here. Second one. That's ugly to look at. Josh, where do you start your second one at? 4 minus what? 4 minus y. That's this line right here. It was y equals x, but he knows he wants y. So it's 4 minus y right there. We take that, we plug it in. Thumbs up if you got a number bigger than 41. Thumbs down if you got a number less than 41. Should have been less than 41. 40.212. 40.212. If you didn't get a chance to type that in yet, please do. All right, so here's what you're doing, you and your neighbor. Okay? On one of your Post-it notes, each of you are doing one of these. Okay, so between the two of you, you're doing one.